Okay. So single stage transistor amplifier means here we are using only one transistor to amplify the weak signals. That's why this is called as a single stage transistor amplifier. Okay. See this circuit diagram. This is the one of the example for single stage amplifier circuit. Okay. So here we have used one transistor, that is common emitter. Junction, and that is here R1, R2 resistances you have used. RE is the emitter. Through the emitter, resistor is connected. Here load resistance 5 ohm, that is output load resistance, that is 5 kilo ohm we have used. Okay. So here input signal, that is 0.1 volt we have used. Okay. So this is the very basic single stage amplifier, transistor amplifier circuit. Okay. So now we are going to study about the single stage amplifier is amplifies the signals, how it is working, and this and all we are going to discuss. Okay. So this is the single stage amplifier. So then there is a graphical demonstration of transistor amplifier. Okay. So how the output signals, input and output signals are plotted in a graph, how it is working, explanation through the graph. Okay, characteristics. Here for a single stage amplifier, in x-axis VCE is there. What is VCE? Potential difference, battery in between collector and emitter, that is VCE. Here IC, output current. Okay, load output current IC. So VCE versus IC graph is there. For different input currents, IB is equal to 5 microampere, 10, 15, 20 microamperes. We have studied in your previous classes what is amplifier and its how it is working. Okay, this graph already we have studied. So if you are increasing the VC voltage, it is reaches some point. It is gradually increasing the current value up to some point. After that, it will. Okay, so this is for different input currents. IB current, it will vary. So now in this, by using this graph, what we are going to study means, so here we are in single stage transistor amplifier. Okay. So the main motto is to amplify the weak signals. That is AC signal we have given as input. So here is the AC input signal is there. Okay, positive half cycle and negative half cycle is there. You are giving this AC signal. See this 0.1 volt, that is the AC input signal here. Okay. So take it is AC signal. Here is the signal. Okay. So during the positive half cycle, okay, here AC signal is that. During the positive half cycle, what will happen? So its output current IC is increases during the positive half cycle. Output current is increases up to its value. I mean input current value, that is in 10 microampere means. If you four different variables is that, they are taking 10 microampere of IB, a base current. Input current we have given 10 microampere. Okay. So now we are giving the input signal, weak input signal. So during the positive half cycle of input signal is passing through the circuit. So during the positive half cycle of the input signal, what will happen? It gives the maximum amplified output, that is 1.5 milliampere current. I mean output current will come. So again during the negative half cycle, maximum of minimum, it will decreases from the maximum. It absorbed 0.5 milliampere only. Okay, during the negative half cycle. Okay, so it is repeatedly going on in between the amplified output signal. Okay, output current in between 1.5 milliampere to 0.5 milliampere. Okay, so here we have given 0.1 volt. Then the output load resistance, that is 5 kilo ohm. So what will be the output voltage? What will be the output voltage? Here we have current ratio, I mean range between 0.5 milliampere to 1.5 milliampere. Our amount of current தான் வந்து நமக்கு வந்து கிடைக்கும். So if is 1 volt நீங்க கொடுக்குறீங்க, for example நீங்க 0.1 கொடுத்துக்கங்க, for our convenient 1 volt AC signal we have given. Okay, so what will be the output voltage? 1 volt கொடுத்தோம்னா how much of voltage வந்து கிடைக்கும்? Take it is 5 kilo ohm as the load resistance. So just multiply with 5 into that we have to IB value here 10. Okay, so here 1 ampere, sorry, milliampere is there. So 10 microampere is input current and 1 volt is the potential, I mean signal. Okay, signal is 1 volt. So what will be the output output voltage? Here range is 1.5 to 0.5. So in the range குள்ள தான் அதோட அவுட்புட் இருக்கும். அவுட்புட் கரண்ட் வந்து இந்த ரேஞ்சில் கொடுக்கும். ஒரு 0.1 இந்த ரேஞ்சில் கிடைக்கும். பட் இன்புட் current, that is 10 microampere, very minimum amount of input current. Then signal வந்து நம்ம அப்ளை பண்றோம் 0.1 வோல்ட்டுக்கு சிக்னல் அப்ளை பண்றோம். ஸோ output current will be ranging from 0.5 milliamps to 1.5 milliamps. So current வந்து இந்த வேல்யூ அப்படின்னா what will be the voltage? Any idea? Current value is in between 0.5 and 1.5 இதுக்குள்ள கிடைக்கும். Because of positive half cycle, during positive half cycle it will be 1.5, negative half cycle 0.5. Okay, so average range in between 0.5 to 1.5 milliamps. We will do some problems regarding this concept later. After the class we will do some problems, because if you give some voltage, I mean 1.5 volt or 1 volt you are giving, so input is 10 microampere, whatever it may be. So what will be the current and what will be the potential difference, voltage, output voltage and output current value calculate பண்றதுக்கான some problems we will work it out. So just understand the concept, we do the problems later. Okay, students, is it clear what is single stage amplifier, then how it is working? The working principle will explain later. Up to this point, this is the general idea of working of that single stage transistor amplifier. Okay, so this is the circuit diagram, but practical circuits have single stage transistor amplifier and multi-stage amplifier has the very complicated circuit. So you have to analyze, you have to know that analyze capacity of this single stage amplifier. Okay, ஒரு single stage amplifier circuit வந்து எப்படி how it is working அப்படிங்கறத அனலைஸ் பண்ணிட்டீங்கன்னா then multi stage amplifier and practical circuitsல எப்படி ஒர்க் ஆகுது அப்படிங்கறத வந்து based on this concept you can apply the DTS processes. Okay, I mean complicated circuit you can able to apply. Okay, so this is the single stage transistor amplifier. Then the practical circuit of transistor amplifier, that is a very simple circuit, and this is the actual practical circuit of transistor amplifier. Okay, see this here, one transistor we have used R1 R2 the same, here RC, that is the load resistance, here RE we have used here. Okay, so additionally we have connected 3 capacitors. Okay, C, and this is the input capacitor, here CE which is connected in emitter, and CC capacitor that is in connected in collector terminal. Okay, so here RL is the load resistance, RC also resistance which is connected in capacitor, I mean collector terminal. Okay, so here is the signal. Here is the AC signal. We will apply in this area. So once the wake-up signal is applied in the circuit, it will amplify after the this process. Okay, amplification process. It will give the maximum output. So why we are using, already the basic circuit contains R1, R2, RE, RC only, but we have connected three different capacitors. What is the purpose of this capacitor in this circuit? We will discuss one by one. Okay. So various circuit elements we have used in this circuit based on see this circuit diagram. In this circuit, we have used various circuit elements. First one is the biasing circuit. That is biasing circuit. Already transistor biasing circuit you have studied. In this biasing circuit, these components are influences, or this is the only reason for a biasing circuit, that is the R1, R2, RE. These resistance are connected in this transistor. So these are the responsible for that biasing circuits. Okay, R1, R2, and R3. Okay, so this is the biasing circuit. Then second one is input capacitor. See this here in this amplification circuit, we have connected C-in, I mean input capacitor with the base terminal. Okay, so here it is connected, one end of capacitor is connected in the base, another end is connected with the input signal. Okay, so why we are using this capacitor means its value of input capacitance is 10 microfarad. So its value is about approximately 10 microfarad. What is the work of this capacitor? Okay, initially we know that a capacitor allows only the AC signal. It blocks the DC signals. Okay, so AC signal only it will bypass through the capacitor, but it will isolate the DC signals. Okay, so it will not flow, DC signals will not flow through the capacitor. So that's why we are using here using this capacitor. I mean because here we are using AC signals here, it will flow through the capacitor and reaches the base terminal. Okay, so if it is not, this capacitor is not connected, means what will happen? So this AC signal will move this resistance through R2. Okay, in between, these are connected in between R2, across the R2. So the signal will flow through across the R2. So voltage will drop. Okay, so current is flowing through the resistance, means what will happen? Voltage will drop. Okay, so to reduce avoid the voltage drop, so we are using a capacitor. Okay, so this capacitor will isolate the signal from the R2. R2 will isolate panni, it will give as input signal to the base terminal. Okay, this is clear, students, why we are using C-in, that is input capacitor. Why we are using input capacitor in this circuit means this is the reason. Is it clear? Hello students, is it audible to you? Just respond me.
Yes sir.
Yes sir, கேக்குது sir.
ஓகே, இப்போ ஏதாவது கான்செப்ட் புரியல அப்படின்னா நீங்க கேட்டுக்கலாம். திஸ் இஸ் த மெயின் சர்க்யூட். ஓகே, இதை பேஸ் பண்ணி தான் அடுத்தடுத்து என்னென்ன கால்குலேஷன்ஸ், கரண்ட் கால்குலேட் பண்றது, வோல்டேஜ், இதெல்லாம் வந்து நம்ம பவர் கால்குலேஷன்ஸ் இதெல்லாம் வந்து இதை பேஸ்ட் ஆன் திஸ் சர்க்யூட், இதை பேஸ் பண்ணி தான் நம்ம பண்ண போறோம். ஸோ திஸ் இஸ் த மெயின் சர்க்யூட். ஓகே, ப்ராக்டிகல் சர்க்யூட் பேஸ் பண்ணி தான் நம்ம கால்குலேட் பண்ண போறோம். ஓகே, ஸோ திஸ் இஸ் த ரீசன். in capacitor வந்து யூஸ் பண்றதுக்கான ரீசன் வந்து இது. Then third one, emitter bypass capacitor. Here we are using emitter capacitor. So this capacitor is parallelly connected with the RE resistance or emitter resistance. Okay, so it is parallelly connected to the emitter resistance. So if it is through this capacitor, it allows the current, IE current, it will flow through the AC currents will flow through this emitter capacitor. Okay, so if this capacitor is not used here, means what will happen? So its value is around 100 microfarad. Once again, I'll check. Its value around its value is about 100 microfarad. Is correct. So 100 microfarad value, that is CE capacitance value is 100 microfarad. So which is connected and parallel to the RE. RE means emitter resistance. Why we have connected this capacitor means it is to provide low reactance path to the amplified AC signal. So if current is flowing in a circuit, for example, generally current is flowing in a wire. Okay, so we have you have a junction, one junction is there, so two branches is separated, okay, from one wire. Okay, so one end of that branch have connected the 1 ohm resistance. Okay, so another end is which is connected with the 10 kilo ohm resistance. So current is flowing through one end and reaches the junction. In which direction the current will flow? One end of that circuit is 10 kilo ohm resistance is connected. Another end is 1 ohm low resistance is connected. So in which direction current will flow? For example, I'm asking. Students, can you understand the question? Hello, students.
சார் புரியலைங்க சார்.
ஒன்றும் இல்லை, சிம்பிளா சொன்னா ஒரு ஒயர்ல வந்து கரண்ட் ஃப்ளோ ஆயிட்டு இருக்கு. ஓகே, ஒரு எக்ஸாம்பிள் தனியாக எடுத்துக்கிறோம். ஃபர்காட் திஸ் சர்க்கியூட். ஓகே, ஒரு ஒயர் எடுத்திருக்கோம், அதுல வந்து நம்ம கனெக்ட் பண்ணிருக்கோம், ஒரு எலக்ட்ரான்ஸ் ஃப்ளோ ஆயிட்டு இருக்கு, ஐ மீன் கரண்ட் ஃப்ளோ ஆயிட்டு இருக்கு. ஓகே, ஸோ அந்த ஒயர்லயே வந்து ஒரு ஜங்ஷன் இருக்கு, அந்த ரெண்டு எண்டு பிரிச்சிருக்கோம் ரெண்டா. ஓகே, ஒன் எண்டை வந்து one side வந்து 1 ohm resistance we have connected, another side, another end, another side, another branch, that is 10 kilo ohm resistance is connected. Okay, so ஒரு T shape னு வச்சுக்கோவா, ஒரு T shape connection is there, that is junction. So bottomல இருந்து T எடுத்துக்கோங்க, T shape. So bottomல இருந்து current flow ஆகுது. So left end, that is 10k resistance is there, right end 1 ohm resistance is there. In which direction the current will flow? And the side move ஆகும். எந்த சைடு கரண்ட் வந்து ஃப்ளோ ஆகும்? ஹையர் ரெசிஸ்டன்ஸ் இருக்கிற பக்கமா அல்லது லோவர் ரெசிஸ்டன்ஸ் இருக்கிற பக்கம் மூவ் ஆகுமா, ஃப்ளோ ஆகுமா?
Lower resistance.
Okay, that's what I'm asking. Lower resistance இருக்கிற பக்கம் வந்து current will flow, very simple. So the same concept here is using here. Okay, so here resistance is very high, I mean RE. So if you are connecting CE with this circuit, means that AC signal will flow through this capacitor. Okay, so here if it is flowing through the resistance mean what will happen? The voltage will drop. Okay, so we will not get the proper output. That's why we have connected capacitor here, CE capacitor with this. It is connected parallel to the RE. Okay, is it clear why we have connected this capacitor in this part? Okay. At the emitter, we have connected one capacitance, that is CE is there. Okay, so which is connected in parallel to the RE, because so here AC signal will come, so it will if it is not connected means the capacitor is not connected means the AC signal will flow through it and voltage will drop. Okay, so but it will not after the drop you will not get the maximum output. Okay, so that's why we have connected this emitter bypass capacitor. Okay, see here.
Okay, sir.
Is it clear? Okay. Then third one, then fourth one, that is coupling capacitor, that is CC. Okay. So here its value also is about a 10 microfarad value is equivalent to that C in. So its work, it will couple the amplification to the next stage, one stage to next stage. This capacitor is using. So if it is this capacitor is not connected means what will happen here in this circuit? Capacitor in collector terminal, there is a resistance, that is RC is there. So here we have connected CC. Okay, so this CC is not connected in this circuit means what will happen? The bias condition of the next stage, I mean the output current will flow through the RC. RC will drop the current. Okay, the same reason here we are using. Okay, so RC is there. So here also current will flow. So if you are taking output here, okay, in this CC through output they are taken. So this is here we have connected a load resistance, that is output, that's different. So there is a combination between the RC and CC. Okay, so if it is the current is flowing through this direction means, so due to RC has the shunting property. I mean shunting effect. Shunting means it will divert the current to the next direction. Okay, it will divert to the next direction due to the resistance, high resistance value. So resistance எங்கெல்லாம் வந்து மேக்ஸிமம் இருக்கோ அந்த அதில் வந்து வோல்டேஜ் ட்ராப் ஆகும். தென் ஆர்சி ஐ மீன் வோல்டேஜ் ட்ராப் ஆகும், ஆர் அந்த மேக்ஸிமம் கரண்ட் ஃப்ளோ வந்து லோ ரெசிஸ்டன்ஸ் பார்த்துக்கு டைவர்ட் பண்ணி விட்டுரும். ஓகே, டியூ டு திஸ் ரீசன் we are using this collector, I mean coupling capacitor CC. Okay, so that's why these three capacitors are using in this circuit. So basic circuit is R1, R2, RE and RC and one transistor. Additionally, we have connected this CECC. Okay, RL is the output. That's no problem. So here is it clear? This is circuit analysis. So with this circuit, we are going to work it out how to calculate the voltage gain and power gain also. Okay. Okay, students.
Yes,
we have explained what are all the components we have connected, why we have connected with this circuit. That's what we have discussed now. Now we have to analyze the current flow. Okay, so here I1 VCC is connected. So I1 current flowing here, IE plus IE. Here IE, small IE is there. So what are all the current flow? What is small IE, capital IE, IB? இதெல்லாம் என்ன அப்படிங்கிறது டிஸ்கஸ் பண்ணலாம். So one by one. Next, various circuit currents. Okay, so here the circuit is there. So in all directions various current will flow through the circuits.